well on your next exam, so even after failing the third one?
You know, you are happy with the first results of the first two. You're like, I got a 95 and a 92 on these first two, and I'm happy. Or I got 100 and 100, and I'm perfectly happy. Yeah, you don't get third one.
We just not show up. I'm kidding. Yeah.
I'd like to
How
show
far do
up.
you guys get on making a picture?
I would do that too. Yes, you would.
Maybe I won't give results on the first time.
Okay, I'm just curious. I haven't been here, so I'm trying to check. What is
Oh, yeah, if you're happy with it, that's the way this works, yeah.
You know
So if you're happy with the results of your
Okay.
first two exams, yeah, you don't take third one. You don't have to grade it either, so it's win-win. I have another question. So in the labs, for those of you who already had it yesterday, talking about conservation of momentum and energy and those other things. Have you guys had any class talking about momentum and energy for this round? Yes. So I don't need to go over. I don't need to spend time on Friday going over that.
Maybe a little wouldn't be bad as a refresher.
On the exam?
Wow.
But it just comes up in the lab. So I think maybe I'll talk about it a little bit on Friday, not too long. And then also, I think I'm going to talk about significant figures briefly on Friday. Or this ends up being running short on the exam. So, anybody else have homework to turn in?
One question real quick.
Yeah.
You know if John's gonna post the exam the same way?
John. We would post the exam.
Like, you're gonna have to drop the lowest one.
Oh, he's going to drop one?
Cause that's what Carl was gonna do.
I don't have to
I
talk
think that's not fair. You,
I don't know. Talk to Peter about that one. I don't have any idea. Okay. I do not let me get going on this homework. So, I'm going to go over this. Okay, so the first one. We got object. It happens to be the general lead, but for our purposes, it could be any old object. Going off an 8-degree jump at 70 miles an hour. So step one is we need to get to 70 miles an hour into a more useful unit. So we have 70 miles per hour. And then we're going to multiply that by 5,280 feet per mile. We'll multiply that by 1 hour per 3,600 seconds. And we end up with 102.7 feet per second. Okay, so that's step one. Step two, so that's the magnitude of our velocity. Now we need to get this as a vector, which means we need to break it up into components. So this is V naught, the initial velocity. We say V naught equals 102.7 feet per second. Talking about right there. And we're going to take, for the I component, we're just going to take the cosine of the 8 degrees. So we have cosine 8 degrees in the I direction plus sine 8 degrees in the J direction. So that's what we get. So we break this out, do it up, get 101.7 feet per second in the I direction plus 14.3 feet per second in the J direction. Hopefully there wasn't too much trouble with this. So now I'm going to go through and do sort of the integrations, derivations, whatever, in both the X and the Y directions. So start with over here. So in the X direction, we say A sub X of t
1.7t.
That times time.
Yes. So we have 101.7 times, that's feet per second still, times time. And this makes sense because we have per second times time, those are going to go away and it's going to be feet, which makes sense for position. And then again, we have plus v0 in the x direction. And so at this point, it's up to you. I didn't tell you where to set your coordinate system, where to make x0, y0. I chose to have it be the takeoff of the jump. I chose to have it be x0, y0. You could have made another choice. The others are natural choice to me. Would have been to have the takeoff of the jump be x0 and maybe the landing of the jump be y0. I would say those would be the two ones that make any kind of sense. I just went with the takeoff of the jump. So we would jump, takeoff, wherever it goes up this way. I had right here, this is v0. Got homework? I'll accept it at this moment, but not for too much longer.
There was homework due?
So is that a no? No homework?
Not
Okay.
yet.
Alright, good. So, given that, I said P0 is right there, so P0 is just 0. So I can just get rid of this term entirely. P starts off at 0, so that's my position right there. Okay? So now, y direction, same deal.
Are you gonna take off the one teacher?
It depends on how detailed you are. Like I said in the thing I sent out about homework, work matters more, good work matters more than the correct answer. So if you have, you know, you just write down some answers and there's no work to support it, that's not going to get a very good grade.
I mean, I didn't say so. Zero.
Probably
I
not.
just started at the velocity.
Yeah, I mean, if you just sort of took that as like applied, I mean, I'm trying to be rigorous about this and lay it out in the same format so it's consistent. Now, I mean, yeah, you can probably say like, that's just not going to matter. I'm just going to start here. That'd be all right. That would work out. You don't have to be as fully, when I do this and I sort of, sometimes I feel like maybe the downside of my doing it this way, because I make these things look more complex than they are. It's like, I mean, yeah, we could pretty much skip that entirely and that would be fine. But on the other hand, I like to sort of, I don't know, dot the i's and cross the t's and do it in a consistent fashion. So that's how I do it. Okay, that answers the question? So, y direction. Y direction, starting out the same way. So, I have a sub y of t. And so, what is this going to be? Yeah, so what would that be? Yeah. So this is where I'm going to talk a little bit more about student figures on Friday, I think. But as a general rule, keep at least 3. Okay? This is a basic guideline. So it's going to be negative, so I'm going to go with 32.2 feet per second squared. Feet per second. Okay, now we can integrate that. We have Vy. Still not happening in script T. There we go. Of T. So we're going to integrate that, which is going to be negative 32.2 feet per second squared times T plus our V naught sub Y, which is going to be what?
14.9.
Which is going to be the 14.3. So plus the 14.3 feet per second from this guy right here. Alright, we can integrate that again. So position sub y of t. So we're going to integrate this guy right here. So that's going to be negative. What is this going to be? Negative 30.2.2. That's still getting there. What else? T squared. Anything else?
T squared over 2.
Yeah. So this is still going to be feet per second squared times T squared. Well, divided rather by 2. Okay. And then what else do we got?
Find T.
Yeah, I should find T. How would I go about that?
Plug in displacement for X or position.
Yeah. So this guy right here is supposed to be an X. So this guy right here, I want to know where this gets to 250. So I set this equal to 250. So I say 250 feet equals 101.7 feet per second times time. I call it out, and I get, what do I get? I get T equals 2.46 seconds. There's T. Okay, and so now I wanted to ask you how much higher does the jump takeoff need to be than the landing? So what we basically need to know is what's our piece of Y at that time. So we just tossed that value into this. So I'm going to take P sub Y on the T this time of 2.46 seconds. So that's going to equal, I'm just going to divide this, 32.2 feet per second squared over 2 times 2.46 seconds squared plus 14.3 feet per second times 2.46 seconds. And I solve all that out, and I get minus 62.3 feet. Okay? And so, how much higher should my jump be? Should it be negative? Should it be lower?
No.
So what this means is after that much time, I have gone lower. I've gone negative 62 feet in the Y direction after my time, which makes sense it is. Well, it doesn't have to. If I make this time short enough, that would actually be a positive number because it's still going up. In its trajectory, it started coming up, right? And then eventually it starts coming down. So with a small enough T, this would actually be a positive number. It would still be going up. But with the T that I picked, it's coming back down. So that would be the answer, except you get rid of the minus sign. The jump takeoff should be 62.3 feet higher than the landing. That would be wrong. That would mean it would be lower. Okay, so now next part is the velocity. Ask what the vertical velocity was at the time of landing. How would I find that one out?
Plug in the T for VY.
Yeah, so I got my equation.